Welcome to 8th grade science. This will be our first video that we have done so far this year. I do these videos so that you all have the opportunity to watch them multiple times. If you're absent, you can take a look at them and figure out what you missed, or if you're just confused during the main lecture of the class, this allows you to kind of slow things down and watch them at your own pace. If you are doing really well, it allows you to speed things up and get to the practice more quickly. That's why I do these videos, okay? We are going to talk today about, and I want you to write this at the top of your sheet, Bohr models. So we're going to take what we learned yesterday, which is by this symbol right up here that I'm going to put a star by it. We talked about this yesterday, or the last class, but what we're reintroducing, or we're introducing something new, is right down here, all right? This whole space where I just drew the arrow, pretty bad arrow, that's going to be new to us. So this upper left box we're going to do really quick, and then we're going to take some more time in the lower right box. Start by coming up here where it says silicon and draws the arrow. I want you to write element name. This is simple enough. At the top of a periodic table entry, we always name the element. This one is silicon. Next up, the 14, we talked about this yesterday, atomic number. This tells you how many protons there are in the element, how many electrons there are in the element, and it tells you what element we're dealing with. If there are 14 protons in the nucleus, we are talking about silicon right here. If there are 6 protons in the nucleus, we'd be talking about an atom called carbon. If there are 8, we'd be talking about an atom called oxygen. That's what we breathe. What changes the element is the number of protons in its nucleus. Next up, one capital or one capital and one lowercase, that is called the symbol. This is often really big on the periodic table. So silicon's abbreviation is Si, carbon's is a capital C, oxygen's is a capital O. All right. Finally, in this little box, I want you to write mass number, or atomic mass. I'm going to use mass number so you can see another way we can represent it. We learned this last class. The mass number is the number of protons plus the number of neutrons. Now I want us to direct our attention down here to this table. We know a lot of this information. We're going to have to do a little math to solve for some of it. If I'm going quickly and you're confused, pause and rewatch. The atomic number is 14. We get that straight off the periodic table. Then that tells us how many protons there are and how many electrons there are. So you can fill in that there are 14 protons and that there are 14 electrons. Okay. The atomic mass, watch what I do to the symbol here on the table. I want you to do the same. You're going to cross out every part that's behind the decimal point. In 8th grade science, we only care about what is the whole number for the atomic mass. We are going to write 28. That's our atomic mass. Okay. There are 2 more things in that table that we don't know yet. This whole table describes everything about an atom. We're almost there. We have to solve for the number of neutrons. I need you to find space on your piece of paper and follow along with me. I'm going to write that AM, or atomic mass, is equal to the number of protons plus the number of neutrons. We're going to have to do a little bit of math here. It's not tough. So I'm going to go through it one time and then I'm going to give you some practice. We know that our atomic mass is equal to 28. And then right here, instead of P plus, I'm actually going to do this in another color so we can see a difference. The number of P plus is 14 because that's taken from the atomic number. And then what we still don't know is how many neutrons there are. I want you to be writing this with me. Find space on your sheet. Now we need to solve for the number of neutrons. To do that, we're going to draw our balance bar. I want to get this N0 all alone, so I'm going to subtract the constant. That is 14. 28 minus 14 is 14. 14 minus 14 is 0, so all that leaves me on the left side, or the right side, I'm sorry, is the number of neutrons. There are 14 neutrons in silicon. Copy that down into the space. This is where we get to a totally new word. All right? This is totally new. Valence electrons is something we haven't seen yet. And to understand valence electrons, we need to understand Bohr models. This down here is a Bohr model. I'm going to switch to blue to talk about the Bohr model. You'll notice first the center part. I'm using blue, so pay attention to the blue. This center part right here with the protons and neutrons, that's the nucleus. We talked about this last class. Protons and neutrons are found in the nucleus. In this box, I want you to write E minus cloud. Protons and neutrons are in the center, in that dense middle. Electrons are on the outside. They're inside something called the electron cloud. There are rules for the electron cloud. All right? I want you to look at these rules and follow along with me. This right here is the first level of the electron cloud. And how many electrons do we have inside there? I'm going to circle and count. 1, 2. There are 2 electrons in the electron cloud on the first level. That is always the case. On this first ring, there can never be more than 2. So find space on your graphic organizer and write first ring. I'm going to switch colors. 2E minus. There are always 2 electrons in the first ring. Then we're going to go up to the second ring, which I'm tracing with my pen. You can do this if it helps you. Now let's count how many electrons there are in the second ring. 1, 2, 3, 4, 5, 6, 7, 8. 8. Come up to where we wrote first ring, and I want you to write all other rings. In every single other ring, there are 8 electrons. All right? We know that we have 14 total electrons in silicon. We included 2 on the inner ring, and then we included 8 on the second ring. That only makes 10 electrons. We have to find 4 more, so we need to add a third level. You can just keep adding levels to your Bohr model until you've made all the electrons. I'm tracing the third level. Now we only have 4 electrons left, and we know that each electron level in the Bohr model has room for 8. So I go ahead and I put inside 1, 2, 3, 4 electrons inside that outer ring, and I'm done. These electrons on the outermost ring are special. These are called, and use this box, valence electrons. Valence E minus, you can abbreviate. Valence electrons are the electrons that are on the outside of the atom. They're on that outer ring. We have 4 in this case. Okay, so I'm going to come with my marker. I'm going to turn it back to black. And I'm going to draw 4 right there. There are 4 valence electrons in silicon. For today, all we're going to work on is identifying the number of valence electrons. Next class, we're going to talk about how valence electrons lead to reactions in chemistry. But for today, you just need to be able to fill out these Bohr models and determine how many valence electrons there are. In this example, we did it by drawing our rings. Remember, we have 14. We drew our first level. I'm going to use green to make stars. This is our first level. We filled out 2 electrons. We went out to the second level. Then we filled out 8 electrons. We went out to the third level. We only had 4 remaining. We filled those in, and that is it on that Bohr model. Okay? The hardest thing today is going to be this valence electron practice. If you go slow, you'll never make mistakes. Put in the first ring, add 2 electrons. Go to the second ring, add 8 electrons. Keep going out, adding 8 electrons to each ring until you are totally done. All right? I'm going to have a second video that's going to help you with more practice drawing Bohr models. This is the end of video number 1. Great job. Y'all made it.